Next, we're going to see the relationship between pressure and volume. Now, it was found that when you decrease the volume of a container, so you can see here that the piston is moved down, so the volume of the container has decreased, and we can see that the particles are closer to each other. Because they're closer to each other, there's going to be more frequent collisions with the particles themselves and with the walls of the container. So this is going to increase the pressure of the gas. So according to Boyle's law, the volume is inversely proportional to its pressure at constant temperature and when number of moles of gas is constant. So this is the relationship. So pressure is inversely proportional to volume, right? Now, if we are going to use this as an equation, you cannot use it when there is a proportionality sign into this. So we're going to insert a constant. So we're going to do pressure is equal to a constant K times 1 over V. Right? So pressure is inversely proportional to volume. So P is equal to K over V. You can see the inverse relationship here. So when pressure increases, volume decreases, vice versa. Right? Now from this, you can see that if I send the V on the other side, P times V is equal to K, or P times V is a constant. Which means that if we have two different containers of the same gas at the same temperature, the pressure and the volume in the first container should be equal to the pressure times the volume of the second container. So PV is constant for any gas at a fixed temperature, the fixed number of moles of the gas. Right, so this is an equation that you are going to be using in calculations, and when you're using this equation, the units of pressure should be the same and the units of volume should be the same. You don't have to convert everything to SI units as long as the units that you're using on both sides are the same. Right, now you also need to be able to sketch the graphs of these relationships. So pressure is inversely proportional to volume, so P is equal to K over V. So this sketches like this, P against V sketches like this. Now if I'm going to sketch pressure against 1 over volume, so we can have pressure is equal to K times 1 over volume. Then it becomes direct relationship, so pressure against 1 over volume, there's a direct relationship, so it becomes a straight line. Now, pressure times volume, if we rearrange this, P times V is equal to K. So pressure times volume is going to be a constant K. So it does not change, you get a straight line. So pressure, if we plot pressure times volume against V, or pressure times volume against P, it's still going to be a straight line because pressure times volume is a constant. Now we're going to apply this relationship in a question here. So it is said that the balloon has a volume of this. So this is V and a pressure of 101 kilopascal. So if this is V1, this is P1. And when it rises, the atmospheric pressure reaches this. So this is P2. Calculate the new volume in dm cube. So we need to find V2. So this is unknown. So temperature stays constant. Amount of gas is constant. So we're going to use P1 V1 is equal to P2 times V2. V2 is unknown. Therefore, V2 is equal to P1 times V1 divided by P2. You have to rearrange to subject of formula, and then you just apply the values. And here I'm not converting anything because the unit of pressure is the same and the unit of volume is the same, so I'm not changing any unit. So you just calculate it and you get the answer.